Hello and welcome to Sefasok Academy the Intellect on YouTube. In this channel, we are out to help the advanced level science students to attain the academic excellence and the academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. In this video, we are looking at June 2023, Advanced Level Physics Paper 2, Section A, Question 3. And if you are new in this channel, I'll invite you to subscribe to the channel and turn on the notification bell to be among the first aware of our uploading of videos. So in the question reads, in the process of producing lasers, atoms of the active medium are excited from the ground state n equals to 1 of energy E1 equals to negative 11.24 electron volt to n equals to 3 of energy E3 equals to negative 1.38 electron volt. These atoms then fall back momentarily to n equals to 2 of energy E2 equals to negative 5.82 electron volt. They are then stimulated by a suitable energy photon to fall back to n equals to 1 level. It said define the following words and expressions used in relation to lasers. A. Optical pumping. B. Population inversion as used in the production of lasers. C. Explain why the laser beam has a high intensity and calculate the wavelength of the light produced. So we go directly to the solution. A. What is optical pumping? Optical pumping is simply the use of light or EM radiation. EM radiation then stands for the electromagnetic radiation as a source of energy to atoms to raise them to a higher energy level. So optical pumping is the use of light. It's not the light itself, but it's the use of light or the EM radiation as a source of energy to atoms to raise them to a higher energy level. So the B part of the question asks us to define population inversion. You are first of all hearing the word inversion. So it's a situation where atoms, particles, electrons, or molecules are more in a higher or excited state than in lower or ground state. That is the meaning of the inversion there. The population there stands for the atoms, particles, electrons, or molecules. And then the inversion is what? The higher state than the ground state. So that's the definition of population inversion, which is a situation where atoms, particles, electrons, or molecules are more in a higher or excited state than the lower or the ground state. So the C part of the question is to explain why laser beam has a high intensity. So why laser beam has a high intensity? This is because it has a high number of electrons, making it transition from higher energy levels to lower energy levels to be within a short period of time, or to be simultaneously done. Or you can still say that what laser beams are highly collimated. That means that what it does not spread. Collimated means that it is straightforward, it does not spread. So it is because of a high number of electrons which make the transition from higher energy levels to lower energy levels to be in a short period of time there. So the next is, so we should calculate the wavelength of the light produced. So from delta E equals to h c all over lambda. So there we have the energy of the radiation. I've published a video on photoelectric effect. I will allow the link in the description or in the commentary section so that you can watch the video on the photoelectric effect. So that E there stands for the energy of the radiation. E equals to delta E equals to, normally it's E equals to hc all over lambda, but now there, since we have different energy levels, I'm going to have that delta E. Since energy is neither produced, energy is neither created nor destroyed, then delta E will be hc all over lambda, which is the energy of the radiation, where the lambda stands for the wavelength of the radiation, h stands for the Planck constant, of which I've done a video on that already, and then c stands for the speed of the radiation. So we calculate. You imply that what hc is equals to lambda is equals to h all over delta E. Okay, so we have that delta E here will be E2 minus E1. Why E2 minus E1? Simply because they said the atoms left from n equals to 1 to n equals to 3 and then momentarily came to what? N equals to 2 energy levels. So that is our point of reference. And then they said it is stimulated by a suitable radiation to fall back to n equals to 1 level. Okay, so that is the two energy levels that are using E2 and E1. We are not using E3 because it went to E3 and then momentarily comes back to E2 alone without any stimulation there. So we just replace the values for us to have for the Planck constant here, which is 6.62 times 10 to the negative 34 joules seconds. The speed of light, or the speed of the radiation, is 3 times 10 to the power 8 meters per second, divided by E2 is negative 5.82 minus E1, which is 11.2. So I'm putting here times 1.6 times 10 to the power negative 19 because it was given in electron volt, and 1 electron volt is 1.6 times 10 to the power negative 19. You will have more details when you watch the video on photoelectric effect there. So when you calculate it properly, you will have that the wavelength of the radiation is 2.31 times 10 to the power negative 7, or you can still say that E, or lambda, is equals to 230. Sorry, this one is 231, not 230, because you shift it to 2 decimal place. 231 nanometer, because nano is times 10 to the power negative 9, so it's 231 nanometer. So guys, we have come to the end of this video, and if the video is interesting to you, like I always say, I'll invite you to like the video, subscribe to the channel, and then share with your friends for them to also attain academic excellence. And not forgetting that in science, consistency is the key. And also, just a small reminder, this video was proposed by a YouTube fan, so you can propose your video on the comment section and I will see on how to produce. You can propose your topic or the GC here on this comment section. I will see on how to produce other videos on that. And don't forget that in science, consistency is the key.